Hiya. Now, I could say I was asked to go over this question, but the fact is I wasn't. I just love doing this so much, I really wanted an excuse to have a go at it. Okay, so I'd have a go. But anyway, it's one I thought that maybe you found interesting, difficult, challenging, all of the above. Maybe you just have a look to see how I have a go at it. Okay, so you've got x over sine squared x. Now I'm hoping this is an obvious statement, but you want to rewrite that, don't you? Okay, you want to rewrite it as x cos x squared x. Okay, because with the by parts formula, you want to have a product, something times something else. So write it as this times this. And then you decide what you want to have as u and what you want to have as dv dx. Okay, so u is something, dv dx equals something. Have u as x. Most of the time, when there's algebra involved, you want to have u as x most of the time, because that way you can diminish the powers of x. Okay, in other words, if you have u as x, then du dx is going to be 1, you see, and then by parts application you won't have the x term there. I'm hoping that makes sense. If not, just follow through the next steps. That means, of course, then that dv dx is going to be cosec squared x. Okay. Now these are given to you because you should know, or at least remember or recognise, that there is a standard result for that, the integral of cosec squared x. If you're still not quite confident, then you might want to just look it up, okay? Or you just have a go at it and then you just look it up to check, okay? But you should get, that is negative cot x, okay? Let me just help you out with where it is. So, yeah, it's this page, you see, so page 294, and see, there, rule number 8 says integral of cosec squared x is negative cot x, okay? So that's that one, and then we just use the by parts formula. So you got the integral is equal to uv, so that's that times that, negative x cot x. Subtract integral of v du dx, so that's negative as well, so that's going to be positive. Integral of cot x dx. Okay, I'm just going to work out the integral of cot x actually is. Okay, so we have negative x cot x plus, this is another one you've got to be able to remember, okay? But these ones are slightly easier. I can understand that you might struggle having a, you might struggle to remember what that is, okay? But cot x, let me just show you. Let's see if this comes out. Okay, it's a different colour pen, blue. So with the tan x and the cot x, you write it in terms of sine and cosine, okay? So cot x, of course, is cos x over sine x, yeah, dx. And do you remember what kind of integral that is going to produce? Okay, it's going to be a natural logarithm, isn't it? Okay, the reason I say isn't it is because you've got a fraction there on the denominator, you've got no higher powers, so it's like sine x to the power of negative 1. Okay, differentiate the denominator, you get the numerator. That's your classic case of it's a natural logarithm. Okay, so it'd be natural log of, and then let's not forget the modulus brackets, sine x, like that. Okay, so cos x over sine x, natural log of sine x. You can just check, of course, when you differentiate that, you're going to get 1 over sine x times by cos x. Because that's just a generic result, I'm going to put in the plus c there. Okay. Now then, when you look up the actual result, okay, on page 294 again it was, where is it? Oh, it's not there. Hang on, it'll be there somewhere. Oh, it's not there either. Well, it surprised me because I thought it would be sort of there somewhere. Okay, but well, if it is somewhere and I've just missed it, please let me know. Okay, but anyway, that's what you get. Okay, so what that means is this integral of cot x, that's just going to be natural log of sine x. Okay, plus c, and yeah, that is it. Okay, hopefully you found that helpful. I want to do another one.